Welcome to chapter 5, which is the equilibrium of rigid body. Yeah. So in chapter 5, at the end of the chapter 5, students will be able to identify the support reaction and draw the free body diagram. So this will be the first part, which is in this video, I'm going to cover 5.1 and 5.2. Yeah. So stay tuned. So we have the application. You see, the first diagram here. Yeah, the first diagram here is what your real life image is. Yeah, and then in order for us to do our free body drawing, we make it into a idealized model. Once the idealized model is ready, we convert it to free body diagram. Free body diagram isolates. You see, in idealized model, you have the ram, you have the rope or the tie, the cable. Yeah, but in a free body diagram, if you see, it's only one object at one time. So if you're talking about the ram, then you only draw the ram and you draw all the forces that's exposed to the ram. That's it. Yeah. If you draw the rope, then you're going to show the forces that's acting on the rope. Yeah. So that's the rope, free body diagram of rope. Okay. So in this chapter, we will be covering on how to draw the free body diagram, yeah, and then also to see the condition. Since that we are in statics, yeah, statics means non-moving, and the equilibrium is actually the body is in equilibrium. You know what's equilibrium, right? Is in a rest position. It's in a very well contended situation. Yeah, it's very happy. It's not moving anywhere. Yeah, static. So in this case, where your total acceleration will be 0, or the velocity is constant, or it is totally in statics, in not moving. Yeah, so there's no translation, there's no rotation. So summation of all the forces will be 0. Yeah, so we're going to come to that shortly. So this is the process involving the free body diagram. You have your idealized model and then you draw your free body diagram. So in your exam or in this chapter, the most important is actually the free body diagram. I don't give marks for the idealized model. There's something for you to know. I only look at the free body diagram. Can you see if this beam here, this is the free body diagram. Now, your next question can be, how do I know whether it is 2 forces or 3 forces or 4 forces? Isn't it? Yeah, like you're given this thing and I tell you to draw, then you can ask me the next question. Dr. Dewika, what about age here? How many force do I draw? Like in the ram here, why is it 2 forces? Yeah, why is tension only 1 force? There's a cable there. Why is it 1 force? So I'm going to come to the next part where I'm going to show you how many forces and how do you do that. Okay, this is a roller. You know what's a roller, right? Edges of a bridge. Yeah, end of a bridge, if it's a metal bridge expand and contracts based on the weather condition itself. So most time in a bridge, yeah, the end of the bridge is always a roller and this end will be a fixed support. Yeah, this kind of rollers exist. Sometimes it's not visible to your eyes, but they exist. And then we have smooth pin and hinge. Okay, you are an engineer, you're an engineering student, so you need to know all this thing, and this is fixed support. Now, each of the type will have its own forces. Like example, look at this fixed support. We have 1, 2, 3. Okay, and then you have smooth pin or hinge. We have 2. And then roller, we have 1. Oh, what's happening here? Yeah, how do we know this? Okay, I'm going to show you something in your textbook. Yeah, just move on to your textbook. Okay. Well, I don't know whether it's bad news or good news to you, but you need to memorize table 5.1. Memorizing table 5.1 is compulsory. I repeat. Yeah. Table 1.1 will show what kind of connections and how many reaction forces will be there. Example, cable, we have 1 force. Weightless link, we have 1 force. Roller, we have 1. Rocker, 1. What's the difference between roller and rocker? A roller allows the object to actually move laterally or horizontally, yeah, rolls over, but rocker will just shake, like sort of like in the same position, but it allows it to rock, yeah. And then we have smooth contacting surface, 1 force. And then we have roller pin. Wait 1 second, yeah. We have roller and pin, also 1, yeah, in confined smooth slot. And then we have collar, 1 as well. And then we have smooth pin and hinge, 2. And then we have a member fixed in the connected to collar on the smooth rod, also 2. Fixed support, we have 3. So the bad news is you need to memorize this table. Next question, will it be given in the final exam or in the test? No, the table will not be provided. So you need to memorize the type of connection, and only then you'll be able to draw the free body diagram. So this is the real life drawings that are collected for you. Yeah, so the floor beams, they're welded together, so they are forming fixed connection. Some of this is visible, some are hidden, so it depends. Yeah, so this is a concrete girder. Can you see? Look here, there is a cable exerts a force on the bracket. So this is like something that you can see. Yeah, maybe it is exposed so you can see. Now this is a rocker. Can you see? It's below a bridge girder. Yeah, it allows some movement. Yeah, why? Because if it's a fixed support, it will crack. Because sometimes, you know, there's vibration, there's expansion due to the weather, contraction due to the weather. So you need a bit of movement. Yeah, okay. So next would be internal forces. Every object has got its internal forces, but then in this lesson we do not discuss about the internal forces. Internal forces comes on chapter 7. Why? Reason being because we only look at external, because internal forces most of the time cancel off each other. Okay, they are there, but they comes in collinear pair, so they cancel off each other. So that's the reason why we don't expose the internal forces. Now weight and gravity, center of gravity is always pointing downward. Yeah, it's always pointing downward. Yeah, no way gravity is actually pointing upward. Yeah, so the moment you have something, any question where they ask you to actually ask you to draw the weight, yeah, or they tell you the weight is taken into account, so you need to draw the weight, which is always pointing downward from the G. What is G? Your center of mass. Okay, center of gravity. Okay, that is W. And then idealized model, the one that I've explained earlier, that's idealized model, but we look at free body diagram. So now I'm going to explain to you on example 5.1 before I end this first part of the video. So draw a free body diagram of the uniform beam, and the beam has a mass of 100. Can you see that? They have actually they have actually mentioned on the mass, so you cannot ignore the mass. Yeah, so let's look. This is the question. Now you need to, what's given to you is an idealized model, so you need to draw a free body diagram of the beam. So when you draw the free body diagram for beam, so you draw this beam, and then you draw the 1200, which is given in the question, so do not delete it, and then you can draw the weight. Okay, the weight is mostly right in the middle of the beam, so it is, how do you get 981? Because 100 kilogram multiply 9.81. Yeah, gravity is acceleration. Okay, the H here, can you see this H here? Suddenly you have 3 here. Okay, what's happening? So let's look at this. This is a fixed support. So how do you know fixed support? You need to go back to the table. Yeah, once again, I'm telling you, in the exam, it's not given. The table, can you see this table? It says fixed support, right? So what does fixed support tell you? How many forces? We have Fy, Fx, and moment. Fy, Fx, and moment. Three unknowns. So you need to copy that 3 unknowns here. So that's the reason why you need to memorize the table. Yeah, otherwise you'll not be able to draw this free body diagram. Drawing free body diagram is extremely important, because without the free body diagram you will not be able to proceed to the next level of calculation. Yeah, so with that, I'm ending this video. Please do upload all the homework that is assigned to you. Yeah, I'll meet you in the next video. Thank you.